say if we had a curved curtain wall, we would have to come in here and select, move this. Sorry, I just wanted to get this aligned. So if we wanted to make a curtain wall along this panel, I would go and use our array along a curve, select that curve, and we can specify the distance. So let's go, 4 feet or something. But what if later on in the design you realize, wow, I have way too many mullions, or hey, I want to change the profile of those mullions. Now, you can use the blocks as we just did to change the profile, but it would be more challenging to change the distance between these mullions. And it would actually just be faster to go ahead and delete all the mullions and rearray it at a different size. But if you have lots of different elements in a bigger project, this would take a lot of time to run and fix, and you're going and you're deleting items and then recreating them. It's not a very efficient way of doing something. So what we can do here is use Grasshopper. Now, don't worry, we're going to use it in a very basic way, and it's probably good just to know that Grasshopper exists, and it's something that you can later on go and learn more about. So we're going to open up Grasshopper. Now with Rhino 7, Grasshopper is integrated. In older versions, if you have Rhino 5, I think 6, I'm not sure. Definitely if you have Rhino 4 or 5, Grasshopper is a separate program. They have now integrated it. Okay, so we have opened up Grasshopper, and Grasshopper is linked to Rhino, but we have to link the elements ourselves. And so in order to do that, what we can do is double click, and we're going to type in surface. Now you'll notice, how do you link these two items together? What you have to do is right click and hit set one surface, and now you are linking an element together. Now when you select it, this should turn green, and you'll know that these two items are linked. You can do simple things like move this surface in Grasshopper. So I can take this surface and I can set targets. So it can translate a motion, which means I could type in a X value, 20, and I could set the height. So the advantage of Grasshopper is being able, well, this is actually going to set the x-axis, so not the height, is being able to very quickly dynamically change something without manually changing it. So you can give it lots of inputs, and at any point you can change those inputs, and it's going to update this live surface. Now the surface doesn't actually exist yet. I would have to hit bake, and now it's a baked object. It's cooked. So now the only way to move this is to manually move it. So the reason why people love using Grasshopper is it allows the ability to give lots of information, data, points, and always the ability to adjust something anywhere from the number of levels you have in the building, even the number of windows, the height of something. It all can be dynamically changed within Grasshopper. And there is just an endless list of things that you can do with Grasshopper. But for now, what we can do is generate mullions. And this is actually, it's not too difficult to do this. Just kind of follow along, and don't worry if you don't completely understand how it all works. That takes a long time to really start to understand all the data and numbers and how Grasshopper works. It's fine. Just kind of follow along and trust that this method works, and then over time you'll start getting a familiarity with it. But don't worry about just knowing the program right off the bat, because it does take time. A lot of rambling. Let's get into the example. So here we have a generic surface, and Grasshopper, it needs data and points in order for it to work. It's based off of mathematical properties that it can manipulate and deal with. So right now, this surface doesn't really have any attributes and we can't really do anything with it. So we have to give it points and values in order to manipulate those points and values. That's the simplest way that I can think through this in sort of a more intuitive way. So the first thing we're going to do is hit divide surface. And so what divide surface does is it takes a surface, we give it a couple rules, and then it's going to export either the points, it's going to give us the normals, which is the perpendicular direction at a given point, and then it's going to give us a UV as a tree of points, so series of data points. So we're going to type in our surface, and right away you can see that now we have a bunch of points on our surface, but we want to be able to control those points, how many points and in what direction, and that is where we have the U count and the V count. So we'll type in 20 and 20, and you'll notice that now we can control how many points we have on that surface. Pretty cool. Okay, so we have points, and we can take a look at what is this item, this tool going to give us? What is going to come out of it? So each one of these visual programming scripts is basically giving us data. So we're giving it something to evaluate, and we're giving it data, and then it's going to shoot out other type of data, and then we have to figure out what to do with that. So we have a series of points, and if you think back to our previous video on sweeps, so if you think back to our previous video when we went over sweeps, that gave us a lot of flexibility to take two curves and create any custom shape that we wanted. So let's do that in Grasshopper too. And so I'm going to double click here and type in sweep. And we're just going to do sweep 1 for right now. And you'll notice that if I type this in, I can see what are the inputs that it needs. It needs a rail, so it needs curves. It needs a section of those curves, and then it needs a miter. It doesn't actually need a miter, but that's an additional input that you can give it. Okay, so how do we get there? And this is sometimes how I think about Grasshopper, is I give it the last result that I want and sort of reverse engineer it to figure out how to get to that specific area. And a lot of the times it's not intuitive, and you just need to start to learn the tools, and you'll kind of then start putting the pieces together. It needs a rail, which is our first curve that it's going to reference. And I know here that I have a series of points that I can work with. So if I double click and I hit interpolate curve, this creates a curve based on a series of points. I can click that, and I can take my series of points and create a curve based on those points. And just quickly, you'll notice that the curve is going in the right direction or orientation because it's reading the data in a specific way. You might have this surface in another orientation, I'm not sure, but just so for you to understand, sometimes what you need to do is use the flip matrix, and that allows you to take your points, because this is just a list of points here, list of points, and it's reading those points in a certain direction, but there's a way to flip that direction, and now it's interpreting those in a list in the other direction. So sometimes you just need to flip those depending on the orientation. In this case, I don't need to do that, but very frequently I'll need to do that just to kind of manage the data. Okay, so we have our curve. Awesome. So we've input our rail, but now we need our section as a list. And unfortunately, we can't just make a curve and then give it that curve and it's going to sweep along all those rails that we've created. It needs a little bit more information than that. And this is, again, it's not intuitive, but just hang with me. So what we need to do is be able to create a curve, but then orient that curve along this list. And so let's type in orient, I'm trying my hardest to make this intuitive. And you can see here, so we need to orient geometry, and what does it need? So it needs geometry, and then it needs an initial plane. So let's create some geometry, and I'm going to double type curve, set one curve, and then it needs a initial plane. So I think I can just do this, type in the curve, and then we'll give it a point, and we'll just give it a reference point here, set one point, and we'll put the point in there. Okay, so we have our geometry, and then we have a curve. Then it needs a base point. It needs a target for those items. So that's kind of what I meant by the orient. Unfortunately, this is not smart enough to orient that sweep, and so we have to specify what those what it's going to reference. So we have our curves here, but again, Rhino doesn't really know anything about those curves. It just says it's curves, right? But what we can do is we can do endpoints. Let's type in endpoints, and we can put in our curves, and that's going to give us our endpoints of the curves, which is going to give us reference geometry that it can take and orient with those points. I know, it's freaking confusing and annoying, but this is the world of Grasshopper. Now we have our geometry, and you'll notice that it's already oriented along those points. So pretty cool. So before we did that, I had nothing to orient this geometry to. We type in those sections, and you can already see that this curve is referencing along those the geometry. And then you'll notice if I move this point, it's going to move the reference to the point. So that's kind of just bounding it to where it needs to be. Then we can take that geometry and then extrude it. So it's just extruding it between those 2 points. As you can see here, the geometry is not rotating perpendicular to the surface at each given point. And what we did initially was we took the curve and found those 2 endpoints, picked one of the endpoints, and that was our base. So it was giving us the proper base of the geometry, but it was taking the default X and Y as the orientation. So it oriented the geometry correctly and extruded that, but it didn't, the plane defaulted to the default X and Y. Sorry, lots of words. So what we have to do is figure out what is the perpendicular direction to each one of these points, and then rotate the plane first, and then plug that plane into B. And then we would have the correct orientation. So here, what we were originally doing here was the curve, taking the endpoints, and then plugging that into the base plane. Now what we're going to do is, as you remember, we had our normals as a tree. So the normals give you the perpendicular, they give you the perpendicular direction to a given point on the surface. So there, under this curves, there's actually a couple primitive commands or primitive elements that can take the normals of something. So you also can use this circle normals. So this will take a normal. So let's just try this out. We take the normal, and then it wants the center point. And we take our center points. And you'll notice that it will create a series of circles that are perpendicular to that point at that particular surface. So if we change the direction or the curve of the surface, these circles will always be perpendicular. And yeah, I mean, we can go into further explanation on this, but it can you can do a lot with it. So if we had a bunch of points, then we could basically, let's say we had a bunch of points, then we could have a bunch of elements that would come off of the surface, and it's always perpendicular. But for right now, we don't need to worry about circles. Edit, delete, and we can turn this back to 1. Right now we can just use the normals for what is called this line SDL. So if we come up to here, you will find this line SDL. And what's great about this is it takes the direction, and so we can plug in the normals into the direction, and then we're going to take the points and plug those into the direction. This is actually just for something else. Okay, so if we select this and we zoomed in, we would see, we would see all those green lines, and it does give you a length. So if we want to see this more clearly, let's give it a longer length, and so you can see those perpendicular lines. Okay, so we have a perpendicular line, and right now it's selecting both of them, and I only want to select the top ones. Again, what we're going for is we're trying to create a plane that's going to orientate in this direction. And so the way that I figured this out is not by just looking up a solution, which I did initially but didn't find anything helpful. I looked at all the different ways that you can construct a plane, and then thought about what are the ways that I can take advantage of to construct a plane. So originally I used this line plus point, didn't find any luck with it, but then saw this construct plane 3 point and thought, okay, I can get 3 points. That's something that I can kind of figure out how to do. And so I placed this 3 points and took a look at which aspects does it need. So it needs an origin point, and it needs a point in the X direction, and it needs a point in the Y direction. Okay, so we needed only 1 point. So if I select this, this was selecting 2 lines, and so we needed to only select the ones on the top. So set this one to 1. So now we're only selecting that first tree of lines. So those are our lines. And again, I'm thinking back, okay, I need to have these orientation points to work with and deal with. So the first one is the X point. So it only needs 1 point. So if I gave it 2 points, it would fall in an error. I just need that one endpoint. And if we type in point here, type in point, you can see that it's now selecting that 1 point. So that gave us our X direction, and then we just gave our orientation point that original one here. So again, let's just type in point so we can visualize this. That was selecting that origin point of the plane. Now this one was a little tricky. We needed the Y direction, and at first I just plugged in this segment here thinking that it would pick that one, but it actually needs to be something 90 degrees to this point. So I thought, okay, I know how to take a line and rotate that 90 degrees. So that's what I did. I took all those lines and then rotated them 90 degrees. Then took those points, and voila, I get the endpoint. So let's type in point, get the endpoint, and I get the endpoint, which is not always 90 degrees to whatever is perpendicular to that point. Then from there, I'm able to create a series of planes that are all perpendicular to the surface. This is really cool, and this is what makes Grasshopper so satisfying to figure out, because you're always trying to reverse engineer what you actually want to do. So I knew that it needed a base plane, and I knew that I needed to have a plane that was perpendicular to my surface, and I had to reverse engineer different ways that I could construct planes based on the information that I can create. And, you know, honestly, I tried multiple of these and they did not work. Finally, I stumbled upon the 3 point, and that was a way for me to create a plane. There could be an easier way to do this. If you find one out, please let me know, and I'll be glad to hear it. I'm always curious to learn easier ways to do things. And then once you have this geometry too, like, you kind of know it as a set of rules. And so I can also come in here and I can either group these together, and then I can also cluster it together, so create a little cluster. And then I've created my own custom component that I know that if I have a surface and I have points and I need to get perpendicular planes based on those points, I have this nested component, and you can customize it, and anytime you can go in here and change those attributes. All right, and so now let's turn on this geometry, and you can see that. Let's close this out a little bit. You can see that now this geometry, and let's just so you can see the script itself here. So that's the script itself. And then let's take this geometry. Now you can see that each one of these pieces are perpendicular to the surface, and then we did our extrude, and now we have our mullions that are perpendicular to the surface. Please let me know if you have suggestions for videos. I'm always taking suggestions. Leave comments below what you thought of these videos. I know I went through a lot of explanation, but the reason that I did that is because there's just so many grasshopper videos out there that don't explain what and why they're doing it. And yes, you learn how to do that one particular thing, but that doesn't teach you how to learn and figure out things on your own. And so that's why I painstakingly explained my thought process of figuring out this script, because my hope is when you're trying to figure out your particular thing that you're doing, you can start to use this methodology of reverse engineering to figure out how to do stuff. And sometimes you just have to make it more simple in order to figure it out. Oftentimes you would think a very easy thing to do actually takes a lot of time to figure out how to do something very easily. So you would think that you could just get the perpendicular plane on a particular point, but you notice that there's all this gymnastics that we have to work through in order to get the information in order to complete it. But once you have it, and you can copy and paste it, you can save this, you can keep the script and keep using it and adjusting it. All right, enough talking. Thanks for joining again. Please comment on things that you figured out, things that you're frustrated with in Grasshopper, all that good stuff. Let me know in the comments below, and I'll see you around. Thanks for joining.